Hello, this is Mr. Huff, and I've had a few emails about the Excel assignment, so I want to go through just the first three or the first section, and I think if you have that one, then we can talk about the rest of it. So you're going to fill out the spreadsheet, and this works the same on Excel and on Google Sheets, and probably on whatever it is on Apple, but that doesn't translate very well, just things you can turn in on Canvas. So Google Sheets or Excel are suggested. I also saw a problem where people were doing the work in Excel on their laptops, and then it was saying, okay, now you need to sign in before you can save it. So just highlight everything, copy and paste it over into Google Sheets. It should bring the calculations over with it, so that shouldn't be a problem. All right, so let's look at what I've set up here. I have height here, and I'm going to enter a practice value of 4,000 meters. And that's going to give you something to kind of look at. So if I give you a height, you should be able to change this to any number that you want, and the calculations will work. So we're going to be looking at that. Notice I colored it yellow so that indicates that someone's going to put something in right here. And these are calculated, so I colored those blue using the little bucket here just to help me understand what I'm looking at when I use this. So the first thing we're going to talk about is temperature, and it's going to be in degrees Celsius. Pressure is going to be in kilopascals, and density will be in kilograms over cubic meters. And you can just put in the cubic meters like this, and you don't have to include the degrees. I will know what you mean if you just type this. All right, so let's look at the first equation. If we look at the slideshow about atmospheric conditions, you will see that if you know the height, you can calculate the temperature. So ignore the units. That's not important for putting the calculation in. You need the numbers and the variable. So we've got our variable here. This is the height. And then we need these two numbers. So let's go put this into Excel. I've already got these copied over here, so we can just paste them in. So if we go right here, and what I did is I'm going to double click on this. So if you look at this, it says equal and 15.04 minus parenthesis 0.00649 times B6, and B6 is the height. So all you have to do to put that B6 in is click on that cell, and it points to that. So that way, if you change B6 to anything, it sticks it in this formula. When you're done, you hit enter, and if you're using my numbers here, it should be about negative 10 degrees Celsius. So next thing we're going to do is calculate the pressure. So if we look at the formula, you can see it's right here. We have the standard pressure times the temperature converted to Kelvin and divided by this Kelvin number here and raise it to this exponent, which is really, really strange looking. So let's go plug this into Excel. So here we go. So I type that in. So this is what it would look like. Let me zoom in on that a little bit so you can see what's going on. It's not letting me zoom. So, oh, it's because I have an active cell. Okay, so equals and the pressure times parenthesis, open a second parenthesis, take the temperature, which is right here, add 273.1 to it, divided by, close parenthesis, divide by the number on the bottom, close that parenthesis, take this expression from B9 to the end of 288.08, raise that to the 5.265 power. When you hit return, you should get something like 61 kilopascals. Keep in mind that at sea level, it's 101. Typically, that's our standard pressure. If you go higher in altitude, the higher you go, the lower that pressure should be. So any number less than 101 as you increase altitude should be reasonable here. All right, so the next one is the density. So for density, we have to use temperature and pressure. So let's look at what that would look like if we plug those in. Okay, I zoomed in a little bit. So here's our calculation. We are taking B10 divided by everything in these parentheses. And we use the number from the formula times the temperature plus 273.1. So we are converting Celsius back to Kelvin for this calculation. And that should give us our density of the air. And we put that in and we get this number here. So for density at sea level, it's about 1.2 kilograms per cubic meter. And as you increase altitude, that should decrease and decrease and decrease. So you should see numbers that are less than 1 for density, usually at any kind of altitude. So if this works, we should be able to go up here and change this number. and everything changes. So we have a lower temperature, we have a lower pressure, and we have a lower density. If we bring it down to like 150, we can see we have a higher temperature, we have a higher pressure, and we have a higher density. So let's put 4,000 back in just for the sake of this example. And that's how it goes. One more thing I want to point out. Let me look at the formula here. I noticed some people weren't using the asterisk to multiply. They were trying to use the parentheses. Excel only sees parentheses as separators. It does not recognize that character to mean multiply. And it works like that on your TI calculators, but not in Excel. Something to keep in mind. So these are the first three calculations you have to do in the assignment. Keep going from there. I hope that you find this helpful and have a good day.